Before we learned what the technical components mean and how we basically soldered them together, now we go to the next stage, the actual configuration of the drone. So you need a micro USB cable and two things. When you connect the flight controller, you don't need any battery because the computer will power the ESC and you can do all the configurations directly on there. If you want to work with the air unit and if you want to work with the ESC, or if you want to do some configuration on the ESC, you need the battery, but I will show you. So first we're going to connect the ESC with the micro USB cable, and then we're going to switch to the Betaflight configurator. First of all, what you have to make sure, usually it's that USB modem and then a very long number. So you basically connect now, and I would always recommend to enable the expert mode, as we are going to be experts. So what you see on the first page is basically use the accelerometer, and you can see when I move my drone, it's also moving on that picture. What is important, you can also see that arrow. So when I go to the front, that arrow should also, or like that image should also show you what I'm doing with my drone. The first time you basically upload a new firmware to your flight controller, or the first time you're gonna basically configure it, I would always suggest to calibrate accelerometer. But the first thing I always suggest you to do, you go to this CLI tab, and what you do is you type BL. I'm not gonna do it now because then it puts, and the BL means bootloader. So you put BL and then you press enter, and then the flight controller would go into the boot loading mode. And you need that because then when you're in boot loading mode, you can go to the firmware flasher. You can select the board which you have. And then you're gonna select the firmware automatically, and you're gonna here you see flash firmware. So you want to flash the new firmware via this firmware flasher. But as suggested, what I would do is always go connect your drone, go to that CLI field, type BL for bootloader, press enter, and then you're going to switch to the firmware field and install it. Once you have done that, you come to this image, and then it asks you for like, do you want to apply these settings? You always say yes, apply. You calibrate your accelerometer, and now we go to the next field. So first, port tab. Before, in the tutorial, before I explained you what the UART means. So that's actually where you have to remember where you put the things. So if you connected your Crossfire to UART1, which I did, you see here serial RX. And the serial RX is where you put your controller, the Crossfire. So if you connected your Crossfire to RX and like R1 and T1, so RX1 and TX1, which is the same, by the way, you also want to, with the UART1, enable serial RX here. Then we connected, for this drone here, we connected the DJI Air unit or the Vista, we put it to UART2. So that means the RX2 and the TX2, or R2 and T2. And basically you have SBIS also there, because we've learned that with the Air unit and the Vista you have this SBIS cable, and that's why here on the configuration MSP you have to enable that here. That's important. So controller is RX. Remember the number, that must be equivalent where you put it on your flight controller. And here UART2 is SBIS enabled. That's basically where you connected your Air unit. I also have a GPS on this drone, and that's important. When you have a GPS, remember the GPS also has a RX and a TX. For me, I have it on the UART4. That means you go all the way, not this one, not this one. Here sensor input, because it's a sensor, and you put here GPS. And here you also have, we call it like the baud rate. I put mine to the highest number. So the baud rate means that, like, that's basically signal oscillation, the speed of when you transmit data. So the higher the baud rate, the more data packages can be transmitted. Some of the GPS, you can basically read the baud rate when you buy it. I suggest to use that number there. You can also play around, use the higher number and see if it works. I have mine put here. Once you have done these 3 settings, and if you cannot remember, you can also just play around until it works. You press save and reboot. And what it does, it brings you back to this page. You have to reconnect again. And we have done port. Now we go to the configuration tab. So the first thing you have to learn is the rotation of the props. So if you look at the drone here, and if you look at the picture here, more important, you can basically define the rotation of the props. So you have the props either spinning that direction or that direction. And I'm going to show you the rule. Here you see 1, 2, 3, 4, and you have to keep that in mind when you configure it. It could be that the one here is not the actual one on your drone. It could be that if you let motor 1 start up, it's the 4 starts. So you need to configure that as well later on, and I will show you how you do it. So what you have to keep in mind is you always have counter rotations on the axis. So if you have one prop going into that direction, you need the other one going basically into the opposite direction, because each motor, when it spins, it gives like a momentum, and you have basically these momentum, they have to cancel each other out. That's why, like on one axis, the motor is spinning in that direction, the other one needs to spin in that direction. And when you look at the props, you can also see you want to have that, we talked about the pitch before, you want to shuffle the air. So don't like always have like the props installed that it shuffles the air, not that you shuffle it in the wrong direction. So when you think about the rotation, there are like 2 options. One is, now imagine you have like the drone like in front of you. You can have, if you look at the drone, you can have the prop spinning inwards, and then the one on the bottom, they also have to spin inwards. But what I suggest is you have the prop spinning outwards and the same like going outwards on the bottom. And that's exactly what you see on the picture. This one is spinning up, this one is spinning up, so both spinning like upwards. And here they spin down, and here they spin down. So everything is like spinning away from the drone. Why I like this, if you fly and you have like props which spin like in the other direction, which is also possible, so inwards, and you cut some grass, it's gonna put that grass on your lens, and it's basically limit your view. So I always go with like props who spin away from the middle body, like you can see on the image here. Yes, here you can also like define different like setups, but that's basically, oh yeah, and here you can see basically now it's spinning inwards or it's spinning outwards. So you have to basically, if you tune your motors that they spin that way outwards, you have to also basically define it here. If you don't, also click this button here. If you start it up, the drone starts spinning. So please keep in mind when you configure it away, that's motor direction reverse, that's what I recommend. Also enable that when it's not enabled. So the next thing is, we talked about flight controllers before, and one of the biggest thing I recommend is if you buy a flight controller, go with the F7 flight controller, because the higher the beta, like the beta flight gets new and newer updates, and with the newer updates, there are like new algorithms, new logic, but they mostly also need more processor power. F4 were nice back in the days, but now we have like bidirectional D-shot, which I will show you, which is like a special configuration to make a smooth flight behavior. For that, it's good if you basically buy a F7 processor. If you have an F7 processor, you go here with 8 kilohertz, and you cannot like change that in the older beta flights. You could change that now that it's fixed. So for pit loop frequency with the F7 processor, you're going to change 8 kilohertz. If you have 4, you should go with 400 kilohertz. If you have an F7 and you go with 8 kilohertz, you're going to select bidirectional D-shot 300. That's what I suggest. And if you go with 4K, you can select bidirectional D-shot 600. So that's what I suggest, and works really nice. Then what you also want to have enabled is bidirectional D-shot. You want to have that enabled, And here the motor poles, most of you will have 14 here. That's basically, you can also count it on the motors. That's how many magnets you have like in the motor. And here the 5.5, that's basically the idle throttle value. That means when you arm your squat, the prop starts spinning. The drone is not flying, but it's spinning. And when you fly and you go to 0% value, the drone starts like falling down. And the higher this number, the higher like the props spin when you give 0% throttle. So if you type, for example, here 4, that means when you go all the way down, like 0% throttle, it falls faster than with a high. So for example, with a Cinewhoop, it's really good because you go through tiny little holes if you have a low number like 4.5 or even 4, because if you want to act quickly, you want to have like a fast descent. With motors like with drones like the Freestyle Quad, I would go maybe with a 5, 5.5, should be fine. What can also be done is, we have seen at the beginning, we have this orientation. And some of the drone, like, because the frame always limits how you basically put your flight controller inside, it could be that with the movement of the drone, it doesn't match with the image. So you know that you have to basically reconfigure the orientation of the flight controller. So if you move and your movement is not actually the same, which on that image, you have to do certain configurations. And basically what you have to do is here. So you can have roll degree, pitch degree, and yaw degree. And what you have to do is here type, for example, 90 degrees, minus 90 degrees, 180 degrees minus. Play around with these three things. You cannot break something. Just try to get by changing this angle. And it's also like when the flight controller is sit like this, or the flight controller is like sit like this, or the flight controller is on the top, you have like X, Y, and Z axis. And of course, if you change the orientation of the flight controllers, these axes will change. So you need to play around with these numbers with like plus 90, minus 90, 180. And what I have seen is I mostly have to change one of these like by plus or minus 90 or like 180 degrees, and just change one at a time and see. And that should fix the orientation, and then also that image that works for you. You want to have the arming angle on 180 degrees. That's really important. If you crash and if your drone is not perfectly laying, you want to have 180 degrees arm, otherwise you cannot arm it. Really important, do that. And then here for the receiver, we use Crossfire. That's why we put serial bait receiver, so S-Bus, that's what I explained before. And the CRSF, which is Crossfire, you can select that. These you have to enabled, otherwise it doesn't work. Then OSD air mode, I would leave that with dock. That's really important. I use that. That works fine. And now when you have a GPS, you basically enable the GPS here. You use the u-blox protocol, and you can have auto configuration. I used Galileo. That's available in the new Betaflight version. And set home point once. That's for me, because if I want to land in the middle, I don't want to have like a new home point. So I have that as well. So this is like basically the configuration which I recommend. The other thing you don't need to touch. Oh yeah, accelerometer, turn that on when you have it. If you don't have a barometer or a magnometer, just turn it off, because if you have it on, it steals a little bit from your processing power. And yeah, you want to have that you want to have it somewhere else, basically, that processor power, especially if you have a F4 processor, which is less powerful when it comes to calculation. For example, this Hobbywing 4-in-1 from Johnny FPV, the blue one, I used that back, that's a F4, and then you cannot like, it's good if you turn these things on. Battery, we leave that, I haven't touched it. You have that in the OSD of the DJI goggle, which is doing a pretty good job. Here, when you basically, you have the cell minimum voltage, cell maximum voltage, that's fully charged and empty. So that's the good thing is, I haven't explained that in the battery section, but what you have to consider is a fully charged battery is always 4.2 volts. That's fully charged, independent of 4 and 6S, because the only difference is that you have 2 cells more. But the voltage for each cell is the same. So 4.2 cells is maximum, and 3.5 cells is completely empty. That's where you have to land. The 3.8 is where you want to store it for flights, or yeah, if you're at home. Having a fully charged battery over a long time destroys your battery. Having an empty battery also destroys. So if you fly and leave it for months, that's not good. Try to have it in your storage voltage. That's yeah, gives you like, they last the longest then. So that's the other thing. Fail-safe, really important. You can have fail-safe stage 1 and fail-safe stage 2. And basically what you configure there is what happens over here, for example, after 4 times 0.1 second, and that's meaning with the controller, if you have 4 times 0.1 seconds, not a signal, then it fail-safes. That means the motors turn off and it's literally going to fall down. Why that? If you just fly and you lose your drone, you don't want that the drone starts flying away. That's really dangerous. What you can also do, and here you type in fail-safe stage 2, and that's actually, you can say it drops, or you can have GPS rescue if you have your GPS system. And that's basically, you can enable that. I have it here disabled because I was at the place where GPS was very weak, so I knew I have to disable it. But you can basically turn the GPS rescue on. That means instead of the drone falling down, if you fly 2 kilometers away, it's like going up. And here you can see the angle defines how the drone is flying back, with what angle. You can say, okay, the initial altitude and the descent distance. That means basically if the drone comes, when it's coming back and it reaches 200 meters away from you, it's just like literally gonna drop from there. You can have like the ground speed, how fast it's coming back with the throttle. You can have the ascent rate. That's basically how fast the drone is like going up. You can define how many satellites. I would recommend 7 or 8 to be safe. So that means only when you have like 8 satellites, you can arm the quad. If you use a beeper, you will hear it. When you try to arm the quad and it doesn't have enough satellites, you cannot arm it. The props doesn't spin. And once you have like 8 satellites, you can see that it starts spinning up. You can also have this option that you can arm it without the satellites, but I would not recommend you that, because then you never know if you have enough satellites, and maybe when it fail-safes, it flies in a completely different direction. I think also when you try out the GPS rescue, you need on the controller, I said before, you want to have like the crossfire, you want to have it to cut. That's one of the good important options. And you need minimum 200 meters away from you before you can test the GPS rescue. Like if you're closer to you, the GPS rescue doesn't work. So you need 8 satellites, 200 meters away from you, and 50 meters in altitude that the GPS rescue is to work. And there are 2 types of GPS rescue. One is on purpose and one is not on purpose, like on fail-safe based. On purpose means you don't know where you want to fly, and you basically have to, with a button, press GPS rescue. Then the drone, what it does, it immediately flips in your direction. It's going up to the predefined altitude, like 80 meters, 50 meters. That's what we have here. You go up, and then it's like flying backwards until like 200 meters away from you, and then it like starts dropping. Don't think it's gonna land nicely. It's literally gonna fall down, and you have to basically take over again with the click of the button again. When you have like a GPS rescue triggered by a failsafe, that means if you lose the signal of your controller, the drone basically does the same without you like basically pressing a button. But what you have to do is when you, for example, lose the image, it fail-safes, you basically put the GPS rescue on as if you have pressed it, then the drone is coming back and you basically take it over by a clip. There's also a really nice tutorial by Nurk. We'll put it in the description. Nurk is also one of these FPV pros. Also helped me in certain scenarios, super helpful for that. And I will put that YouTube tutorial in the description, because in 20 minutes he explains you literally everything you need to know to set up that GPS.